Hi there. Welcome to this lesson on Further Pure Mathematics 2, and we're on Chapter 1, 1.1. We're looking at inequalities in this lesson and the algebraic methods involved in solving them. Solving algebraic inequalities. Now there's a few things. When manipulating algebraic inequalities, it is important to remember that multiplying or dividing by a negative value will change the sign of the inequality. So if you have an inequality with greater than, if you multiply or divide by a negative value, that'll change to less than. If you multiply or divide by a variable or an expression, you have to take very great care. Basically, you shouldn't do it because the variable or expression may be positive or negative, unless you take care to make sure it isn't. Now, the easiest way to do that is to only ever multiply or divide by a squared expression, something which has been squared, because then you know that you're multiplying or dividing by a positive quantity. Now, this can help, and on the questions that we're doing, it does help, but on other questions, it can complicate things quite a lot. Factorizing and drawing a sketch tends also to be useful on these types of questions. We'll be dealing with algebraic fractions in this lesson, which will be part of the inequality. The first thing that you have to do, certainly seems to be the easiest way forwards on these questions, is to multiply by squared expressions that are designed to remove any fractions, getting rid of the denominator of the fraction. Once you've done that, it's just rearranging the inequality and normally doing work on factorizing to collect terms together to find what are called the critical values. The critical values are just the values where the function will cross the x-axis. These are the values that will matter when you come to write your answer. Some people sketch a curve to read the answers from the sketch. I always do that, but I'm conscious that quite a lot of people are quite happy doing these questions without ever making a sketch at all. Okay, as an example for you to have a go at yourselves first. So bearing in mind what we've just been saying, have a go at solving that inequality. Pause the video, come back to me when you're ready. Okay, we'll have a look at this together. So we said that if you have an inequality that involves an algebraic fraction, usually the best thing to do is to multiply through by a squared term. Now, in this case, it's going to be x minus 2 squared because x minus 2 is on the bottom of the fraction. So multiplying through by x minus 2 squared will give us that. And now you can see the reason for doing it. We can divide the top and bottom of this fraction on the left by x minus 2, and that will get rid of the fraction. So we've got x squared into x minus 2 now is less than this. Collect all the terms on one side. I think the left-hand side is easier for the moment. You can multiply out the brackets at this point if you want to, but you'll probably waste time if you do. These questions are normally set up so that they are easier and quicker if you factorize as much as you can. Now, in this case, we've got x minus 2 in both terms. So we'll take x minus 2 outside the brackets, and that will leave us x squared minus these terms inside the brackets. Then we do need to multiply out. And that'll give us what we have here, x squared minus 2x plus x minus 2, when we multiply out those two brackets. Then collecting together these terms in this large second bracket just gives us x minus 2 times by x plus 2 is less than 0. And this is the point where some people don't do a sketch. I always do. I like sketches. I like to see what's going on. The critical values are plus and minus 2. Those are the points where this curve is going to cross the x-axis. And if you were to draw a sketch of it, that's what it would look like. It's a standard quadratic with a crossing point at minus 2 and a crossing point at plus 2. Now, going back to the question has said, you know, when is this less than x plus 1? We've rearranged things and rewritten the question as saying, when is this quadratic less than 0? Well, it's less than 0 when it's underneath the x-axis. So that's between minus 2 and plus 2. And that would be the answer. The answer is that x has to lie between minus 2 and plus 2. A note of warning on these questions, and it's an issue that frequently does turn up. If you go back to the domain given originally, the domain says that x cannot equal 2, and that's because if it does equal 2, you'll have 0 on the bottom of this fraction and you'll be dividing by 0. Now that issue frequently follows through to the answer, and you'll notice that one of our solutions is 2. Now, if it said here less than or equal to 2, that would be a problem, because we've said originally no x can't equal 2. Now in this question it's not a problem, but be careful. Be careful with values in the domain that are not allowed, and just check that you haven't accidentally included them in your answer. And that issue is a real issue in this second question. So a little bit more complicated, this one. Have a go at example 2 yourselves. Pause the video, come back to me when you're ready. Okay, let's have a look at this question together. We've now got 2 terms on the bottom. We've got an x plus 1 here and an x plus 3. And remember, you've got to multiply by a squared term because you need to be confident, you need to be certain that what you're multiplying by is a positive number. So we're going to have to multiply by x plus 1 squared because of the first fraction. Also, we're going to have to multiply by x plus 3 squared because of the second fraction. When I do that, I get something that looks quite complicated. The next thing to do is to cancel. So there's 2 things going on here. We've cancelled an x plus 1 from the top and bottom on the first fraction. We've cancelled an x plus 3 from top and bottom on the second fraction. And we've also moved everything over to the left-hand side. So we've got less than or equal to 0 here on the right-hand side. Now on this question, much more so than the last one, do not be tempted to multiply out the brackets. You'll get quite a complicated cubic that you then have to factorize. Far better to factorize now. X plus 1 and x plus 3 are common to both of these terms. So we'll take x plus 1 and x plus 3 outside of these large brackets. That'll give us x into x plus 3 and minus 2 into x plus 1 inside the brackets. We multiply out the brackets there, the large bracket on the right, which gives us that. Tidying up that bracket gives us x squared plus x minus 2. And that quadratic can be factorized into 2 brackets, so that we get x plus 1 times x plus 3 times x plus 2 times x minus 1 is less than or equal to 0. Now that would give us the 4 critical values, minus 1, minus 2, minus 3, and plus 1. Those are the crossing points on the x-axis. If we choose to draw a sketch, which I will do now, and you get a rather attractive looking quartic equation, which comes down, crosses the axes here at minus 3, minus 2, minus 1, and plus 1. Okay, going back to the question. So the question has said we've got to solve this inequality, bearing in mind x cannot be minus 1, x cannot be minus 3, because the bottom of these fractions would be 0. We want to know when this is less than or equal to 0, so this is equivalent to the question. So when is our graph underneath the x-axis? Well, that's between minus 3 and minus 2, then it's above, and then it's between minus 1 and plus 1. So you've got 2 ranges when the graph is beneath the x-axis. And at this point, the question says express your answer in set notation. Well, since they've asked us to do that, we will do what they have requested. The solution would look like that in set language. And the way you would read this is the solution is x such that x lies between minus 3 and minus 2, union combined with x such that x lies between minus 1 and plus 1. But note carefully this time the signs at minus 3 and minus 1. We've got x is strictly greater than minus 3, and x is strictly greater than minus 1. That's because it can't be equal to minus 1 or equal to minus 3. So although the inequality we're solving has got greater than or less than or equal, we can't use less than or equal in the solution because those two values are not allowed in the domain of the original function. Okay, that gets us to the end of this lesson. If you have the textbook, turn to page 4 and have a go at exercise 1A. Thank you very much for listening, and cheerio.